Welcome class to this session. We're going to discuss about ray diagrams, and basically we are talking about reflection by curved mirrors. And when we talk about curved mirrors, there are various terms that people need to know. You need to know what a pole is, you need to know what a center of curvature is, you need to know what a principal focus is, and many other terms that we have discussed in our previous class, which is going to play in this particular session. So whenever you are given a concave mirror, you want to look at various rays. When a ray is meant to pass through the center of curvature, C, this ray will just go through C, and once it reaches the mirror, it will be reflected back as it is. So whenever you have a ray that is passing through the center of curvature of a mirror, it will be reflected back and pass through the same path it came with. So that is the ray passing through the center of curvature, and that is for a concave mirror. When you look at a convex mirror, when a ray is directed to the convex mirror, that ray will come and it will be reflected back as if it was passing through the other side of the curvature. So that is why you can see it is coming, and this one is imaginary. Remember, the center of curvature is behind the reflective surface. These are reflective surface. The curvature is behind the reflective surface. So we are using the curvature behind the reflective surface, and that is why you're having the dotted lines showing it is behind. And it's also reflected back as in the first case, but in the opposite direction, as you can see. We now want to look at a ray that is now going to pass through the principal focus, F. And bear in mind that F is between C and P. This is the center of the mirror, and this is of course the radius where that particular mirror was obtained from. So the distance between C and F is equal to F to P. So meaning F is at the center between C and P. So whenever you are given the center of curvature and you want to determine F, F is at the middle point. So we want to draw another ray. If you are given that, and here you have, if this is F, and this is the center of curvature, and remember this is our concave mirror, if a ray comes through the focal point, if the ray is coming through the focal point, it will be reflected back in this direction, parallel. So the reflected ray will be parallel to this axis. So when the ray comes through the focal length, it reaches the mirror, it will be reflected back, but remember, this one is parallel to this line. That is for a concave mirror. When you talk about a convex mirror, remember this is figure A, that is a concave mirror. We can look at a convex mirror. Convex mirror. You can draw this convex mirror like that. And we draw this line like that. Remember, I've said the focal point will be behind the mirror. The center of the curvature will also be behind there. Remember, for a concave mirror, for a convex mirror, you shade this other side. So if there is a ray, that is coming through, if there is a ray that is directed towards this point, if there is a ray that is directed to this mirror like that, when it is reflected, it will be reflected in such a manner that you may think it was coming from the focal point. So you can draw this. Then you extend this. So if the ray is coming from this direction, it will be reflected back in that manner. But remember, this reflection must coincide as if it's coming from the focal point of that particular the ray must be assumed, they must be taken as if it's coming from the focal point, which is behind the convex mirror. We now want to look at another example whereby you may have a situation of that kind whereby now the ray is directly hitting the pole. This is P of the mirror. This one will be reflected backwards in this direction. Remember, we have said before, for reflection, the angle of incidence is equal to the angle of reflection. So those angles must be the same. Even for convex mirrors, if you have a convex mirror like this, if the ray falls on the pole on point P, which is the center of the mirror, it will be reflected back, bearing in mind the angle of reflection. The angle of reflection is equal to the angle of incidence. So the two must be equal. We also now want to move ahead and look at images, formation and their characteristics. The image formation and their characteristics. So image formation and characteristics. Want to look at this particular area. We want to look at a few instances whereby, for example, you have been given a concave mirror. Whenever you are drawing a concave mirror, you draw a straight line, but above this you have to put a symbol to signify it is a concave mirror. After that, let me say this is, for example, let us take this one to be our focal point. Let this one be our center of curvature. We want to see the image formation if you put your objects in various positions. We want to begin by putting the object. So you can say Roman number 1. When the object is placed beyond C. When the object is beyond C, we want to see what is going to happen if you put an object behind C. Let us say our object is here and see what is going to happen. Whenever you are given such a case, there are two rays that are going to emanate from the top of this point. So the first ray goes parallel to the axis. Draw a parallel ray to the mirror. That is the first ray. When this ray hits the concave mirror, it will be reflected and it will pass through the focal point. That is our first point. So the first ray goes to the mirror and it is made to pass through the focal point. So you can indicate that. So the first ray goes to the mirror, is reflected, and it has to pass through the focal point. That is the first point you must master. The second one is, the second ray goes through the center of curvature. The second ray will be made to pass through the center of curvature. Like that. And we have said before, if a ray passes through the center of curvature, it will be reflected again to pass through the same path. So where the 2 points coincide, that is where your image will be formed. So this is our image at that particular point. So you can see, if you compare this image and this image, want to write their characteristics. So characteristics of the image. So the first point is, you can see the image is inverted. This one is upright, this one is inverted. So the first characteristic is the image is inverted. Roman number 2. The image is real. The image is real because just drawing this. The image is real because it can be formed on the screen, it can be formed in the mirror. Roman number 3, the third characteristic would be the image is smaller in size compared to the object. So the image is smaller in size compared to the object, and if you so wish, you can also write number 4, image. The image is between C and F. So those are some of the characteristics that you can be able to enumerate for this particular case. If you put the object beyond point C, that is what you expect. And I've said, whenever you are drawing such ray diagrams, you must bear in mind there are 2 rays coming from the very top of that particular object.